Hello everyone. So today we talk about heat, water, and crystal. Okay, what's the difference between heat and work? When the energy flow from the system to surrounding, if it creates a random motion, then it is heat. Okay, then it is heat. When the same energy comes from system to the same applies to when surrounding to system also. Okay, when system to surrounding energy transferred, it uh, a regular arrangement of work. Okay, so it create a regular arrangement of movement of atoms means it is work. Okay, this is the difference between heat and work. Okay. Make a thermal motion or irregular random motion. Okay, but work is a regular motion. Okay, so like if you lift a weight, it is a work. Okay, but when the heat of your coffee is cool down, it is heat. Okay, it transforms as a heat. Okay. Okay, how to calculate work? Okay, work is the force into distance is work. Okay, when you apply pressure, the external p external pressure. So what is work? So force is here p external into a. Okay, the area of the piston and the external pressure p. Okay, length, how much it uh, how much the length, this is the length. Okay, so work is the p external into a into l. Okay, area into length is volume. Okay, this is the difference in volume. Okay, why we put the negative signs? Okay, here we put the negative sign for conversional purpose. Okay, when the work is done on the system, uh, it is positive work. Okay, positive work means the surrounding do work to the system. Okay, here the surrounding is work to the system, so we get the, because the volume is negative here, the volume is reduced, so delta v is negative, so we put additional negative sign so that we get w equal to positive means the work added to the system. Okay, like someone is work for hour. Okay, if you take we are the system, then someone is work for ourselves, it is positive work too. If we work for others, it is a negative work, we lost energy, like. Okay, so that's why the system gains energy, or system, the work is to the system is positive. Okay, um, when the p external is not constant, we have to look at infinitesimal changes. Okay, infinitesimal changes means small changes. Okay, so if you add all this, if you integrate this infinitesimal of work, you get the work. Okay, uh, this is means work is not an exact differential. Okay, uh, if it is a reversible process means the p external is always equal to p. Okay, because I already told that when you do a reversible work, the you slowly move the pistons. Okay, from one position to another position, so that it equilibrium with the external pressure. So the pressure in inside and p external is always equal when the reversible process. Okay, okay, if you take in compression from here to p1 v1 to p2 v2. Okay, we can calculate the work done on the system by two ways. Okay, first, this is the initial state, this is the final state. Okay, first we take the pressure constant and go with 1 to volume v1 to v2, and then volume constant and go to p1 to p2. Okay, and the another way is here to here. Okay, there are two ways. Okay, take the first way. For the first way, you go with v1 to v2. Okay, v1 to v2, v1 to v2, the pressure is p1. Okay, the pressure is p1 and delta v. Okay, here then we go to constant volume. When the volume is constant, and dv equal to 0. Okay, there is dv means the difference in volume. Okay, the volume constant means constant volume. Okay, constant volume means dv is equal to 0, so this term is cancelled out. and P1 dV. P is constant, okay, so take outside the integral, and dV equal to V2 minus V1, okay. So if you take a negative sign inside, you got the P1 V1 minus V2, okay. Like that, if you go this way, other way, first volume constant V1 to V2 volume constant, then you go this way, okay. Here here also volume is constant, so that dv is constant, dv is 0, and take this term only, and p external is here p2, okay. So here p2, and dv is v2 minus v1, okay. So take the negative sign inside, you get this. So got see, you from this is the initial state, okay, this is the initial state, and this is the final state, okay. um, and you see there is no the two works are not same, okay, the two work one and work two are not same, okay. Means the work is not a state function, okay. um, because by following two different paths, first we take pressure constant, then we take volume constant, and the other path is first we take volume constant and take pressure constant. By doing two different methods, we got two different works, okay. So that's why work and heat are not a state function, because it different for different heat, okay. It different for different paths, okay. This is very important, okay. Why it is work is not a state function, and why is heat is not a state function, okay. So means for a cyclic path it is not equal to 0, okay. uh, Heat is also the same. Heat is also for conversion purposes. When heat enters the system, it is positive. When heat leaves the system, you put the sign negative. The sign is very important for each calculations, okay. For historically, calorie means heat needed to raise 1 gram of water from 1 degree Celsius, 14 degrees Celsius to 15 degrees Celsius. Okay, that is 1 calorie. Now 1 calorie equal to 4.184 joules. This is very important conversion. Okay. Okay, what is heat capacity? Heat connects with temperature. It is heat capacity. If you take a box, okay, this is the system. You supply some amount of heat. Okay, dq, okay, some amount of heat, the temperature difference dt, how the temperature before and after the heat, the system temperature, how they change, this is related with the heat capacity, okay. The heat capacity also path dependent, okay. For different path, when you keep the volume constant, you get the heat capacity cv. When you keep the pressure constant, you get the heat capacity cp, okay. The path is very important, okay. How much heat the enters the system, it is depends on the heat capacity, okay. And the heat, so just like if you take an example, if you simply take, okay, dq is 10, okay, 10 joules, heat is energy, okay, take 10 joules, heat capacity is 10. If you don't know the unit, take the equation, okay. Here you know heat is energy equal to joules, okay, and the dt, the temperature is difference is kelvin, okay. So what is the unit of the heat capacity? Simply joules per kelvin, okay. Means kelvin kelvin cancel, joules joule joules kg. So all the equation in all equations should match the units, okay. So if you don't know the units, you can simply draw like this, okay. So heat capacity unit is joules per kelvin, okay, per kelvin into the temperature difference is 1 kelvin, okay. You should the two sides should be match, okay. And the heat capacity is not 10, it is 1, means the temperature difference is 10 kelvin, okay. So then only the 10 joules is equal to 10 kelvin, okay. So you understand this, okay. So when the heat capacity is high, the temperatures, the means it the capacity to the heat, okay. So the system's capacity to heat is the heat capacity, okay. How much you heat applies and how much the temperature is increased, okay. When the heat capacity is high, you put how more heat means the temperature does not change very much. Okay, the heat capacity is more means the temperature is very small. Heat capacity is small means the temperature difference is high. Okay, so you should know the what is heat capacity. Okay, and this is the another way is they you know the formula cv equal to dou u divided by dou t at constant volume. Okay, this is the cv. Okay, so another form of v. Okay, so this is the internal energy, this is temperature. You plot a temperature versus internal energy and differentiate. This is I already told differentiation is and tangent to the slope. This is the tangent uh, and if you this is the temperature. Okay, for this is for constant volume. Okay, for heat capacity for this temperature is A and heat capacity for this temperature is B. Okay, how the internal energy varies, the what is mean by differentiation, how when you change the temperature, how the internal energy varies, that is the heat capacity. Okay, at constant volume it is heat capacity. For at constant pressure it is how the enthalpy varies. We tell about what is enthalpy in later class when the pressure is constant. Okay, when you change the temperature, how the internal energy change, that is the heat capacity. Okay, okay, the heat and work are equivalent, so already told how we can by if you raise the temperature of a water by only putting heat. Okay, heat only. Okay, T1 to T2, and another is by only work. Work means here you make a pedal and by using the mechanical work only you raise the temperature of the water T1 to T2. Okay, because the kinetic energy increases, then the uh, temperature also increases. Okay, experimentally it was found that dq plus dq is equal to zero. Cyclic means the work and heat are independent of path. Okay, so the sum of the work and heat are dependent on path, but the sum is independent of the path. Then only they state that there is a some state function whose differential is dq plus dq. Okay, so then only you they got the internal energy u. So first we know only heat and the energy. Okay, so we can uh, we can easily see in the regular objects how work happens, how heat happens, but we don't know the internal energy. Okay, so the sum of heat and work is the internal energy. Okay, so not dq. Okay, du is equal to dw plus dq. Okay, this is the internal energy. Okay, so already told the each depends on path but the sum is not. Okay, this is the first law. Okay, internal energy du is equal to q plus w. The another form is this is. Okay, when du equal to 0, when du equal to 0 dq minus dq is equal to integral of minus dw. Okay, the circle means the closed path. Okay, here the systems for system heat entered means positive work to the system is positive w. For the surrounding when the heat surrounding in the heat is negative and the work is negative, when you add these two you get the zero. Okay, this is the first law, the energy of the universe is conserved. So this is the conservation of energy is the first law. Okay, so some if the system is getting energy is means q means the surrounding is energy this some amount of heat. Okay, and that is the first law, the energy does not increased or decreased, the energy of the system is constant, it cannot be increased or decreased. Okay, that is the first law. Because somehow the energy is taken means somehow if you got some energy means somehow they lost the energy. Okay, so like that if you take advantage of something is someone is sacrificed. Okay, we take advantage of many things from our parents. Okay, that means they all the sacrifice of their parents, okay, and nothing we get freely, okay. So like that the energy is conserved. If you got something uh, easily, means someone is sacrifice it, okay, then only you got this, okay. So the energy is, if you the system gains energy, means the system, the surrounding is lost energy. If the system lost energy, means the surrounding is gain energy, okay. That is the first law, so you should understand this. Okay, thank you.